really Martin McClure from GeMstone.
Are you sure I'm not? There you go.
I'll do it next time. Give it.
Apparently.
That's why.
Apparently, I'm also the noisy Martin McClure from GeMstone. So, all right. So, GeMstone, a history. So at ESUG this year, after I gave my talk about the 1981 byte issue of Smalltalk, Leandro asked me to do a talk on the history of GeMstone, which is something that I knew something about, but not a lot. So I had to do a bunch of research. But you know, I've been with the company 15 years, and the company is 30 years old this year. So when I went looking into it, it turned out to be, you know, have to go back a ways. But I had to go back actually farther than I expected to have to go back, because our story actually starts in 1913. In 1913, with a man named Lem Sing Ti. And this man is a Chinese immigrant to Indonesia. So this man moved from China to Indonesia, and and there in 1913, in his house, he started hand-rolling cigarettes and selling them. And this was his business, and he did this for quite a while. Now, in the 1930s, sometime, Lem Sing Ti, as was common for Chinese immigrants to Indonesia, he took also, besides his Chinese name, he took an Indonesian name. About 30, 35 years later, this would become legal, or a legal requirement that all Chinese immigrants had to take an Indonesian name. There was a lot of discrimination against the Chinese that way. And I don't know how much pressure he was under, but at any rate, he did take an Indonesian-sounding name. And the name he chose for his family was the name Sampurna. And Sampurna means perfection. And so for his company, eventually the Sampurna company, which he named his cigarette company after his family, using the Indonesian name that he took. And he used this as the logo for the company. The lucky number of the company is 9, as you can see with the 9 stars and the 9-pointed circular element. And the words mean towards excellence. So between him and his wife, the business grew and was eventually passed on to his son. And his son also grew the business. And by 1978, when he passed it on to the grandson of Lem Sing Ti, this was a multi-billion-dollar business. So in 1978, the business got turned over to the third generation, a man named Lem Tin Pao, a man I will just refer to as Mr. Lem. Now, Mr. Lem's Indonesian name is Putera Sampurna. And at the time that he gets control of the company, probably not full control. I think Dad's still looking over his shoulder from what I heard. But he's officially in control of the company. I think his dad holds all the shares still, or many of them. But he's 31 years old at the time that he gains control of the company. And within just a few years, he realizes that he has a problem. And his problem is information. He has to have a man with a briefcase full of papers follow him around everywhere he goes that is stuffed full of data about the 20 or so different companies that he is running. And he thinks there must be a better way to do this. Now this is, 1981, the IBM PC isn't introduced even until the latter part of the year. It's the very early years of personal computers. There is a story that Mr. Lem had tried some kind of TI, I think it was, Texas Instruments personal computer, pre-IBM PC, and had made some input, what it considered an error, which was perfectly logical, and it had done something completely stupid with that, as you might imagine. And he had gotten extremely frustrated with this and thrown the thing out of a 7th-story window. But But he thought there must be a better way. And so Mr. Lem in Indonesia placed an ad in the Los Angeles Times saying, I need someone to form a company to solve this problem for me. And a man called Ian Huang saw this ad and answered it and went to Indonesia and talked to Mr. Lem and came back and said, this is a really interesting problem. I think maybe I can do something about this, but I need the right people. So he had been a student previously, Ian Huang had, at the University of Portland in Portland, Oregon. And one of his teachers there was a man named Mike Mulder. And so he talked to Mike and a couple of other people, and Mike talked to a man named George Copeland, who had written a paper entitled, What If Mass Storage Were Free?, which outlined an architecture much like many of the modern things. Like if you look at MongoDB or something, it's actually using the append at the end kind of storage that this paper was advocating. And so they talked to him, and they rounded up a few other engineers and started looking at the feasibility of an actual business. And they thought it might be doable, and they came up with an estimate, and which was totally wrong. But they came up with an estimate of how long it might take to complete building a special purpose database machine. And they talked to Mr. Lem about this, and he said, okay, go ahead. So in February of 1982, there was a series of meetings between a small group of engineers and managers, and not really much in the way of management at that point. But, and that led to the official incorporation and moving in. On March 1st of 1982, they moved into the 18th floor of this building, which is in downtown Portland. And this building, at the time of its construction in 1968, it was the tallest reinforced concrete building in the world. It is even now the second tallest building in Portland. And they weren't in it very long before they actually moved to the top two floors. The 26th and 27th floors, they had the whole floors to themselves, beautiful views of Mount Hood and Mount St. Helens, and incredibly luxurious furniture. There was a lot of money flowing through the company in those days. The company was called the Servio Logic Development Corporation. So what were they doing up there at the top of this building? Well, what they were doing was building the LEM-1 database machine. And, so it was going to be hardware. It was going to have special high-speed bit slice processors. It was going to read a disk track at a time, all in one big swoop, so that it could process data fast and search disks fast. I mean, disks weren't that big and fast in those days. And I don't think that the actual intent was to power the machine with lightning. And I don't think that the actual prototypes were magnetically levitated. But I do know that the machine was intended to harness the data dragon. Now the software that this machine was supposed to run and the way it was organized was with a thing called BigTalk. Now, you might wonder at a Smalltalk conference, where do you get the name BigTalk? And I don't know for sure, but I do know that several of the original 6 engineers that worked on this product were people that came from Tektronix and had come from the Smalltalk group at Tektronix that had done the very early implementations, from the Xerox Release 1 that that was also released to Apple, that then became Squeak eventually, that worked on that back in around in the very early 80s. So they named this thing BigTalk, and it was George Copeland's. He had sort of a set theoretic model that I'm afraid I can't go into detail about because nobody remembers, and I didn't look up the papers. But he had a set theoretic model of how to make a database, and so they were going to do it along those lines. And so they worked and they built prototype hardware. This is a prototype board. It is a wire wrap prototype, probably from about December of 1982, and it's being held in this picture, and here's the other side of it. So you can see the rat's nest of hand-wired wires. It's being held by Bob Brettel. who is one of the original engineers and who is still with the company. In fact, this was taken a couple of weeks ago in his cube because he keeps this board in his desk drawer yet. And they moved on by the summer of 1983. They had actual printed circuit boards of about the same thing. Those are, for those who remember, those are AMD 29,000 bit slice processors, 16-bit ALU. I think those are, they said those were 10 nanosecond RAMs. It's pretty fast for those days. And this is being held by Alan Otis, another one of the original engineers, also in his cube, also 2 weeks ago. He also keeps it in his desk drawer in a static-free bag. He did admit when he was getting it out, it's probably not necessary anymore. So they worked on this for a couple of years, and they actually produced a prototype that ran and did some stuff and demonstrated it for Mr. Lem. But in the summer of 1984, they decided hardware's moving too fast. All these new processor chips were coming out. The 68,000 had been introduced, and things were moving really fast. It's really expensive to be a hardware manufacturer. This was not a machine that was intended for large-scale production, at least at first. Mr. Lem wanted it for his own business, to improve his own business, and he wanted to kind of keep it proprietary to his own businesses, which does mean you need more than one or two, but you're not going to produce millions of them like Apple does these days. So they decided, well, what we're going to do is we're going to simulate our machine in software. And they had a couple of VAXs that they'd bought from Digital Equipment. So they were going to, so they wrote this simulator in Pascal on the VAX in software, and it turns out they never came back. The hardware kept getting better, faster, and so they ended up just staying with the software. And it was somewhere around that same time that they switched their focus as far as the software. And Big Talk had, as I understand it, some problems. Some of the things worked very well for a database, but some of them, like, you couldn't do complex queries, and there were some limitations. And a bunch of these people, the original engineers and some of the ones that were brought in soon after, had Smalltalk experience. So they decided to build something that was based around the Smalltalk model. And so they actually did that, and they talked about things for a little while, a series of discussions, and they came up with what I think of is a really remarkable architecture, because it's pretty much the model that we have today still in the product, in the GEMSTONE product. And it's this idea of persistent objects that you share between virtual machines, and you share them through transactions. How many people saw my GEMSTONE for Dummies or Introduction to GEMSTONE talk last year in Quilmes? A few. Okay, so for the rest of you, or people who might not be familiar with GEMSTONE, I'm going to really quickly run through it. The idea is that this is one of the very earliest, if not the earliest, object database. That was a very new idea at the time. And all the other object databases, commercial databases that came afterwards, did not, they provided a way of storing object structures and querying on object structures. What they did not do was actually execute an object language, full-fledged object language, in the server, in the database server. But these guys, they said, well, I sort of imagine them saying, but they're objects. You need to be able to send them messages, and they need to be able to have behavior, and that should be true even in the server. So that's what they did. So they built a complete virtual machine, Smalltalk virtual machine, and then you have a lot of different virtual machines that all share effectively. They share the same image. They share the same objects. Now, of course, that's kind of a conflict. I mean, you get persistence with a regular Smalltalk, like Squeak or VisualWorks or VA Smalltalk, because you can just save the image and all the objects go to disk. But that's a single user model. You can't really share things in real time with people. You have to ship them images, and then they fork and try merging them again, and that doesn't really work. But here, this is transactional sharing, and it's a little bit analogous to a source code management system, where you check something out and you work with it locally, and you don't see anybody else's changes to the source code until you're ready to check in, at which point you or the source or the system must merge them together, usually the system unless there's conflict. Well, this does exactly that on an object-by-object level, so that you get a view of the entire world of objects, and then you don't see anybody else's changes to those objects, even if they're saving or committing those changes to those objects. You don't see them. You see the world you started with, plus your changes only. When you're ready to commit, then the system automatically merges your changes with the other people's changes and notifies you if there's any conflicts and fails the commit, and you have to deal with that then, same as in a source code control system. But if the merge goes through, it commits it, and then your view is updated. So now you see not only your changes, but everyone else's. So that's the model. It's that simple, but it's also really powerful because you just work in objects, and you just store your object structures, and things are pretty easy. And that model came really early in the history of the company. The implementation, making it scale, adding other things to reduce the amount of conflict you got, that stuff all got added later, and almost 30 years later, we're still finding ways to do substantial improvements, but the really important stuff came early. So the early architecture looked like this. There was a contest within the company. They said, well, it's not the LEM1 database machine anymore, so what do we actually market this under? And there was a contest within the company to say, who can come up with a name for this thing? And somebody suggested the name GEMSTONE. And they picked that name, and they started naming all the pieces of it after gemstones and pieces of gemstones and things like that. The language that you use as a shell is called topaz, and so on and so forth. So here we have the virtual machines, multiple virtual machines, and these are called gems, hence the logo for that. And they're executing Smalltalk code. This is the early architecture. And they have some kind of client they're talking to, which can be another Smalltalk process in a VisualWorks or something, Visual Age. Or it can be some other server process that's written in C or some other language. But these things are executing Smalltalk code. But the way they get all their objects is they have a communications connection to a process called a stone. And so we have the gem and the stone. And this process did all of the disk I/O for you and all the management of the transactions. So it acted as an object server that could retrieve or save objects for any of these virtual machines. So as time went on, that was what was developed, and it worked at least reasonably well. After a while, now Mr. Lem had also, besides the Servio Logic Development Corporation, there was a parent company called the Servio Logic Corporation, which was sort of an umbrella that invested in a number of startups of technology. There were add-on boards for PCs and disk drive things, and he was investing in a lot of tech startups in a world where startups were really rare. Starting a company was not something you did lightly back in those days. And when they first got the top 2 floors of this building, the engineers were, of course, not on the top floor. They were on the next floor down. The executives and the consultants were on the top floor. But the thought was this was going to be the headquarters for all of Mr. Lem's operations in the States. But that turned out not to happen. He decided he needed to move the headquarters to San Francisco. So some of the consultants and people from the 27th floor were let go, and there was other downsizing. And others of them moved to San Francisco where the headquarters were going to be. So they didn't need the 26th and 27th floors anymore, so they moved the developers underground to the basement for a little while. And then by 1986, they were in this building in a suburb of Portland. This is about probably 15 kilometers west of downtown. And this picture actually was taken in 1986. You can see the little, you can almost read, if you're as close as I am, which I am the only one who is, the Servio Logic Corporation logo there in front of the building. And so it was about that time that they were going, well, let's sell this software. And Mr. Lem was a little reluctant because he first of all, he wanted to make a hardware machine. That was still his idea, and he also kind of wanted to keep it proprietary. But they were saying, no, this could be a product. Let's sell this. So in May of 1986, they started what was officially called a beta program, but it was really a way to just sell the software and get it out there and judge whether there was really a demand for it. And so they started that in May, and in September they made the very first sale. And so there we have the Servio name, and you can see a little edge of the logo sticking out, the 9-track tape that it's on to go on to the VAX of the University of Florida, who this gentleman is from. And the two people here, we have Alan Otis, one of the original engineers at GEMSTONE, and Monty Williams, another one of the original engineers at GEMSTONE. So they're delivering the very first copy of GEMSTONE 1.0 in 1986. And the next month, at the very first OOPSLA, which was held in Portland, partly because of all of the Smalltalk stuff that was going on there between GEMSTONE and Tektronix, and I don't know if anybody else had Smalltalk. I mean, Digitalk had a presence there at some point. I don't know whether they did by then. But there was a booth there, a large booth to market GEMSTONE to the world for the first time. And this is Bruce Schuhart, one of the very early engineers. He was there, and you can see that he's there at the booth. Oh, and we have here, you know, that's a tiger, you know. So Igor showed us a tiger image yesterday, and tigers are a common theme in graphics, it seems. So here's another view of the booth. So we have now we have the tiger image on the screen as well. That's Mike Nassos. He was with the company for about 20 years. And you'll notice what's up there for the Servio Logic Development Corporation. You know, it's this thing. And we last saw that thing here. So it's definitely a Semporna company. Well, in 1987, they decided, well, this VAX and Pascal thing isn't working. These new workstations that are coming out, they're running this relatively newly popular thing called Unix. I mean, Unix had been around for a while, but it wasn't until the Bell System breakup in 1984 that a lot of people really got their hands on it. It was mostly universities that were using it before that. And the Sun workstations were new, so they shipped. They started working on this in 1987, porting it over to C from Pascal for the virtual machine part of it, and they shipped this for the Sun in the fall of 1988. In January of 1989, they moved about 2 kilometers north to this building. And a bunch of things happened while they were there. They were expanding. I think they were beyond their space limits. One of the things they worked on there was a thing called GeODE, the GEMSTONE Object Development Environment. And this was, until it had been a headless server virtual machine with no displays up until this point. They decided to put a display directly on this and have the gems directly talk to the X server so you can interact with it directly. And they wrote what I hear, I never got to run it, but I hear was a really nice development environment. And the development on this started about 1990 or so and went through 1994 when the project was canceled. And they did outgrow their space, which was on the ground floor of this building, and the GeODE group moved to a space in the back of the top floor of this building. But then in January of 1991, there was a major layoff. They cut staff by quite a lot, and the remaining engineers retreated out of the ground floor space and moved into the space that they were now sharing with the GeODE people. And shortly thereafter, they moved out of that space, about 500 meters away to this building, where they stayed for a little while. And that building is, 500 meters away from this building. And in the fall of 1992, they dropped the logic from the name because they weren't doing hardware anymore. So now they were just the Servio Corporation. And after a little while, they moved into the back of the upper level of this building, which is right next door to this building. And they started growing and developing more, and the product had been developing all along. So now you remember we had this diagram where the gems talk to the stone for all their data needs. Well, this is a bottleneck. The stone gets in the way. I mean, the stone's a single point of contention for all of that. So what they did was they added a path where the gems could all talk to the disk individually. Now, they still had to coordinate with the stone for doing certain things like committing so that they didn't have conflict with each other. But they could, if they needed some objects off of disk, they could just read that off of disk themselves. And then eventually, probably two or three years later, they added some caching because this was too much disk I/O. So now what you have is you've got this big shared memory region called the shared page cache. And this is, in a typical installation, this is maybe half the physical RAM on the machine. And this thing is shared by everybody. Everybody talks to that. Everybody attaches to it. And so you go and you look, and if you need a page off of disk that may contain the object you're looking for, you go and you look in here and you see if it's there. And if it's there, you can just use it. And if it's not, then you have to read it off of disk and put it in there, and maybe evict something else if you need to. And so this was a big improvement there. And so time rolls on, and in 1995, the name of the company got changed to GeMstone Systems Incorporated. Like many companies, they found that their product had been selling reasonably well. Large companies were starting to use it. Everyone knew the name GeMstone. No one knew the name Servio. So, name the company after the product. Yes?
In the previous slide, when you added the shared page cache, did the gems still go to the disk, or?
Yes. If the gems do not find what they're looking for in the cache, then the gem will actually read it from disk directly and put it in the cache. Yeah, the shared page cache itself, I mean, there are some housekeeping processes that surround this, but the shared page cache is just a shared memory region, really, so that everybody attaches to. So they renamed the company GeMstone. And another thing happened in 1995 that a lot of us are familiar with. This thing, the J word. So this sounded interesting. It's another object language. It seems to be getting popular. So they did have a few people, start investigating that. And they built a client interface so that you could write Java programs as a client to the Smalltalk server. That is still around, still being used by a number of customers. And they had, by the time that this showed up in a company newsletter as being a new hire, the newsletter was in February of 1997. I arrived in November of 1996. And there were 2 pages of new hires. We had a couple dozen about that time. It was a period of rapid expansion of the company. By that time, there were actually 2 engineers, Alan Otis and one other, that were working on seeing whether you could put Java onto the server. Everybody else was working madly on Smalltalk. We had, it was over 150 people, I think, at that point in the company as a whole, sales and everything, but we were all working on Smalltalk except for those 2 guys. And working on the GeMstone 5.1 release. And another thing that was happening there was no room. I had no office when I got there, no cube. I had a little table and a chair at the end of a hallway because that was the only space there was for me. But they were already working on this building. This is in the same newsletter. This is an aerial view of the building that we were about to occupy. And this was under construction still at that time. And this is the only time in GeMstone's history that we had occupied an entire building of ourselves. So in March of 1997, we moved into that building, and it was there that a lot of Java development happened. So after the GeMstone 5.1 release in 1997, a lot of people got, most of engineering, basically, got shifted over to doing Java. Because they decided to pursue this big time. So everybody got transferred off of Smalltalk. We got moved onto Java. I moved with everybody else, and we developed a thing called GeMstone J, which was an attempt to do the basically the same thing we'd done for Smalltalk with Java. Do the object persistence very transparently, and we also made it into an application server with a J2EE container, and that proved fairly popular, and got some good early sales. We were technically way ahead of the competition like IBM. IBM was, catching up with us because they had 3 times as many people and working on it and much better marketing clout. But in 2000 and 2001, in 2000 we were actually bought from Mr. Lim. He sold us to a company called Brocat. So combining GEMSTONE's application server with Brocat's Twister results in J2EE combined server thing. And let's see, so wholly owned subsidiary, announced June 20th and finalized on August 31st of 2000. Bought the shares, they 2.65 million Brocat shares, valued at about US 283 million. I have seen other numbers, but they're not incredibly different from that. So that's probably at least within a factor of 2 of correct. GEMSTONE will continue. GEMSTONE posted revenues 23.6 million in 1999, 170 employees. You notice that in 1999 numbers, that was a 12% increase in revenues and an 84% increase in Java revenues. Now, if you run those numbers, you will find that most of the revenues are from Smalltalk at that point. But not all was good here with Brocat. Brocat was not interested in the Smalltalk product. They were only interested in the Java product. They repeatedly tried to shut the Smalltalk product line down, even though it was profitable. They were convinced multiple times to keep it going, which is good. An even worse problem was that the Java stuff was not a good fit. They did not understand the technology they were buying. They thought it was much simpler than it was because they had never seen software as complicated as this. We had our own virtual machine, and there was all sorts of things. GEMSTONE attracts people that like to solve hard problems. It's always been that way. It still is that way. And they built something that was relatively simple, and they could not conceive of a software product that could not be more or less completely rewritten in about 5 months. So they also tried some really risky out there moves in early 2001, just as the dot-com boom was becoming the dot bust. And that put them in an extremely bad position. So in May of 2001, they laid off 80% of the Java group, me included, Dale included. They laid off 80% from Java. They laid one Smalltalk person off, because by that point they'd realized that was what was being profitable. They laid off basically all of sales and marketing. They hadn't been marketing the Java products while they owned us anyway, so we had lost complete momentum on that side. So then, almost exactly a year later, August 30th of 2001, from August 31st of 2000, Brocat sold GEMSTONE. Sold GEMSTONE assets to privately held S Group Holdings USA for US 1.7 million. It's a rather different number than we had before. And you notice the S Group. Any guesses as to what S stands for?
Smalltalk.
No. Here's a hint. This is Semporna. Mr. Lem bought us back. So, and then things really went downhill. November, big meeting, Brocat fate to be decided. Late November, declares insolvency. January, the doors were shut for good on Brocat, but GEMSTONE lives on. So GEMSTONE's a much smaller company now. They're about 40 people, whereas they had been 170. So, and they were rattling around in that huge building. So as soon as they could, they moved to this building. And this building is about 500 meters in the other direction from that building. So in this building, now we stayed in this building for 9 years, longer than any other location in GEMSTONE's history. And I was rehired to work on Smalltalk after 1 year of being away from GEMSTONE. And I mean, I started working on Smalltalk the day I was laid off. It was like, okay, I've done Java. I've done my 3 years in the Java mines. I'm done. So I'm back to But, you know, in this building, there were both Smalltalk and Java things going on. So on the Java side, they developed a thing called Facets, which was a simplified version. It was the object database for Java with the application server, the fancy J2E stuff just sort of stripped off and thrown away. It was just the persistence. And the few people who bought this really loved it, and there's still some I think we're trying to persuade to give it up somehow. But they really liked it, but it didn't succeed real well. So the Java team was casting out for something else to do, and they came up with something that eventually came to be known as GemFire, which is a distributed, very low latency object cache system that is written in Java and mostly for Java type clients, although now you can have clients of a number of different languages. On the Smalltalk side, throughout the mid-2000s, we ended up working on GEMSTONE as 64-bit. There were 3 phases to this. We expanded the team to work on these projects because we had customers who were running out of space for their objects, because in the 32-bit architecture with 2 tag bits, you could only have 1 billion real objects in the repository, you know, in your database. So, what's that? We didn't have any actual customers that were actually in production and actually approaching the limit in ways that were not avoidable. I think there was a couple that ran into it accidentally, but you know, that was their application architecture didn't need that. So we introduced an interim version called 2G that had a variable length tag, so that the persistent objects would only have 1-bit tag, and so you could do 2 billion. That gave us a couple more years. And then we did the 64-bit 1.0 version, which used 64-bit pointers internally, but still used a 32-bit object identifier. This allowed your shared page cache to be larger than 4 gigabytes, which was also one of the real performance limitations. With GEMSTONE 2.0, then you could have full 64-bit object identifiers, of which there are 40 significant bits now. So now you can have 2 to the 40th objects, and I think up to 2 to the 53rd bytes in your repository right now. And we're continuing to work on that quite a lot. In 2008, we started 2 overlapping initiatives. The first one was GEMSTONE S 3.0. This was a major rewrite of the virtual machine. It reintroduced the jitter. We had lost the JIT when we went to the 64-bit VM because we needed to get the 64-bit done fast. That was more important than it running fast right then. So we reintroduced the jitter with GEMSTONE S 3.0. And the other initiative was the maglev, which was we modified our VM a little bit and then added a bunch of runtime on top of that to be able to run Ruby as well as Smalltalk in the same virtual machine within the same repository using the same kind of persistence. And both of those releases were the maglev 1.0 and GEMSTONE S 3.0. GEMSTONE S got named S for Smalltalk to differentiate it from Java at some point. Before that, it was just GEMSTONE. Those were both released last year in 2011. So by 2010, GemFire was doing very, very well. It had gone, you know, it started very small, but it was growing fast. Revenues from GemFire were getting about on par from revenues with Smalltalk. And at this point, Mr. Lem sold us again. He sold us to VMware. And this was a much better researched sale. It was a much better match. It was done much more carefully, and it turned out, you know, the VMware organization is a much better fit. They are actually taking really good use of the GemFire product. They are pretty much leaving the Smalltalk product alone, realizing that it's doing fine, just doing what it's doing. And so they did change one thing. In 2011, they decided that the building we were in, that we had been in for 9 years, was not really right. So they moved us here. So I thought you might find this familiar. They moved us back into the exact same space that we had left 20 years before. I am actually sitting in a cube that I think is on sort of the edge of what used to be Mr. Lem's office. And so speaking of Mr. Lin, we're still there today, and we're still improving things, and we're still having a great time doing it. And but what about Mr. Lem? Well, in 2005, Mr. Lem sold the cigarette business to Philip Morris, but he has lots of other business interests. This is the headquarters of Semporna Strategic in Indonesia, and they have many, many interests, from agriculture to finance to, it's hard to know where to start on that. Semporna Strategic is run by the next generation. This is Mr. Lem's son, Michael. He is wearing a Semporna Strategic pin that is not quite the logo that we are used to, because I think that logo went to Philip Morris with the cigarette company, but it looks kind of similar. And there's also the Patera Semporna Foundation. And this is a charitable foundation, the first of its kind in Indonesia. It's a bit like the Bill and Melinda Gates Foundation in the States. They are doing all kinds of especially improvements to the educational system in Indonesia. They grant scholarships, they have programs for teaching teachers, they have programs for certifying teachers, they have millions of dollars going to all kinds of things there. They also have initiatives for empowerment of women and other worthwhile things. This is being run by Mr. Lem's daughter, Michelle. So that brings us to 2012 and a Smalltalks conference, which is not the end of the story. It's the end of this talk, because I'm not going to predict the future. Norm will tell you about the future later and what we have planned. And I'm sure that there's things well beyond our plans. And I really wish, as I close, that I could introduce you to every one of the engineers who has worked on GEMSTONE over the last 30 years. And I can't do that, but I can give you a brief introduction to all of the ones that are still with us in Beaverton.
This is incredible. So, this history, I think this is like, my feeling is that the small community isn't that in general. Because, you know, everybody is talking about Smalltalk and anarchy and Anidas and all the people that we know very well. But in parallel, we have GeStone, which is not just a small enhancement of the small community. This is a huge, it's amazing. And these guys are doing things that are incredible. And have been doing that for 30 years and they keep doing it. Amazing and incredible things. So thank you very much. My question is,
Oh, you have a question.
But my question is, of course, about the future. Not the future in the next 30 years, but what kind of projects is the GEMSTONE team working or if you can give us some ideas.
Well, I think that's sort of the roadmap is sort of the topic of Norm's talk later this afternoon. So yeah, for the near future, that's probably the best thing. And of course, talk to any of us offline, to me or Dale or James or Norm.
I have a question. I mean, you in 1995 just started work in Java, and well, you didn't very well. And in 2008, you started to work with Ruby.
Right.
2008. So, how did Ruby affected GeMstone? The architecture, the business is affecting GeMstone in a better way than Java did? It's not affecting at all?
There's a lot of differences between the Ruby effort and the Java effort. The Java effort was completely separate. We had one initial version where the Java VM and the Smalltalk VM actually were in the same process and sort of interacted with each other. But then we had a large team at that time, and we just rewrote everything from scratch in Java, and we ran it on a custom Java VM. So the products became completely separate at that point. And there was a lot of similar code, and a lot of code that had been shared, but it was a complete fork of the low-level code, and the high-level code was all different. With the Ruby project, they run on the same VM at the same time, and that is the design. Because Ruby is a much closer language semantically to Smalltalk than Java is. So we're doing that. We never had a very big team. We only had a couple of people working on the Ruby thing at any time, so it hasn't affected us that much. There is a little bit of, if you really look very deeply at how we do some of the lower level things that you can see from Smalltalk, there's a couple of differences. You're going to see that the way that the meta class hierarchy works is just tweaked a little bit so that it fits with what Ruby does, and it should be for anybody who doesn't ask for is the superclass of my class named this? Anybody who doesn't do that shouldn't see any differences, but there are a few differences in there. The Ruby product is not being aggressively pursued commercially by VMware. That was their decision at this time, but it is being worked on. There's the Hasso-Plattner Institute in Germany currently has a symposium, or it has a bunch of students that are doing a particular project, and they have the source code to maglev and under license from us, and they are, and the upper parts of the system, the maglev parts of the system, are open source. They're out on GitHub all the time, but these guys have some of the deeper stuff as well, and they are currently working on that, and they are going great. They are moving it from Ruby 1.8 to Ruby 1.9, or at least they're trying to. They've got a limited amount of time to do it, but they have a huge amount of energy, and they're just really attacking that. And that started just about 2-3 weeks ago is when they started working on that, and they've already been just doing great stuff. So there's people out there that are really interested in that, but it's hard to say where it's going to go long term.
But you have to make some changes in the architecture to support the environments. One supports Smalltalk, the other environment for Ruby.
Right. Yeah.
From a technical point of view, was Ruby a good thing or
Generally a good thing, and the environments thing is a generalization of something we'd done to support C-side and package management anyway. To where we had a thing called session methods, where there could be methods on a class that were specific to a particular VM that were not, because usually in GEMSTONE all the classes are persistent and everybody gets the same copy of the class when they log in, but there was the ability to do that. And now that there's this ability to have multiple environments, that's sort of a generalization of that, so you can have up to, I think, 256 or 255 different environments, which Ruby is one of them now. But yeah, there are some additional capabilities that it adds. There's also some things that we haven't fully exposed to public Smalltalk API. Like there's now a regular expression engine buried down in there that it was needed for Ruby, and we've talked about designing a regular expression API in Smalltalk that talks to that library, and there's stuff down there that we could use. So yeah, I think all in all, it's a benefit.
So what do you think is the biggest challenge for GeStone company to survive today?
For companies using GemStone? Or?
To survive as a business, I mean.
Oh. For GemStone to survive as a business. Like any Smalltalk vendor, what you're looking for is new customers. And, the customers we have, it's very rare for us to lose an existing customer, but it does, always happens. No one can avoid that. So yeah, we in 2008 we introduced the free edition for small to medium commercial applications, and we've got a number of people using that. And there's always the hope that, and we have had a couple of people that are saying, okay, this is serious enough for us and big enough, and we're making enough money that we want to pay you. And that's what you want to have. You want to give people, you kind of want to let people start, and if they get really big, then they will be able to afford it and they will want to pay you. So that's, I think, the path for the future.
One more time.